In this section, we're going to talk about timers, one of the most useful pieces of hardware that we usually find on as a peripheral on microcontroller chips. Let's look at how timers work. Do you guys remember flip-flops all the way back in your CSE 230 class? Well, this is the foundation of our timers. Here I've got a simulation of a whole chain of T-type flip-flops. And remember, the T-type flip-flops are built in such a way that if you set the input on every clock cycle, the memory stored in the T-type flip-flop will toggle. Right? So here I've actually got them set up in a chain so that the clock goes into the clock section of the first one and the inversion of the output goes into the clock section of the next one. So it actually only transitions to, or it only toggles, the second one only toggles on every second clock cycle. The same thing happens for the next one, so that it triggers on every fourth clock cycle, then every eighth clock cycle, and so on and so forth. So what we have here is a binary counter. As I trigger the timer, it counts up in binary. As I trigger the clock, it counts up in binary, and if I know the frequency that the clock is ticking, now it's a timer. I know how many steps have passed in however long it's been by looking at the value that's stored in the counter. So this is the most basic timer. We know what the clock frequency is, and we know what value is stored in the register that represents the state of the counter. That's pretty much it. We're just counting clock cycles. If we know the frequency of the clock, we know how long in real time has passed since we reset the counter. So now let's take this a step up. This is a representation of a basic timer. So in this case, we have the same clock source embedded in the design, when I toggle it back and forth, I have my counter increases, right? But in between there, we have what's called a prescaler. And what a prescaler is a tiny little counter that sends a signal when it overflows. And what we can do is we can set this prescaler to different values, and what happens is it divides the clock, slows down the clock by whatever value we put into it. So I can set it, let's say, set it to 8. And now as I transition, I have to do 8 transitions before I get one output transition on the outside, on the world in the outside. So I have to do a whole bunch more work. I have to go through way more clock cycles to get one increment in that register. Right? So that's the first piece of hardware. The next piece of hardware is called a reference register. And with this reference register, what happens is when I put a value in here, say I want to put 15, the idea is I can automatically generate a signal when my counter register matches my reference register. So if I go ahead and click and increment along here, ticking, ticking, ticking. Oh, and it's, of course, in hex. Now that I've gone one tick past that, I can see that I have my reference match has occurred, and I can go through here, right? Which is super cool. So now I've got something that allows me to generate an event when I've met a certain timer value after a certain amount of time has passed. I have something that allows me to scale how fast it ticks using the prescaler, and I can also do some really cool stuff by letting the clock run, and I can also have it set as free as reset. So this will self-reset as I go. So let's see if I can get the clock to run here. Start ticking. So the system is going to tick every about 2 times a second. So as we're watching here, we can see that the counter register is increasing, and once it gets up to 15, up past 15, we should see it generate the reference match bit, and then because I've got reset set here, it should, once both of these are on, it should automatically re-trigger to reset and start the counter over again once I've hit that particular number. You can see that the counter already reset for me. We passed that little reference match bit. I think it went by a little bit too fast. Let's see if it happens again here. 14, 15, 16. Yeah, it was really fast, and it happened inside of this thing. So normally we'd latch into some other register and we could see that reference match bit go. My simulation isn't perfect, but you get the idea. Is we have a system that resets, and it also performs comparisons for us. And this is what real timers can do in our peripheral hardware. In the rest of this section, we're going to look at the capabilities of timers and how we can get them to do work for us, particularly in counting and generating events, generating pulse width modulation, waveforms, and how we can use them to make real-time delays.